If an object is moving with constant acceleration, we can derive three equations to describe its motion. Here's the first one. So we have an acceleration versus time graph. If the acceleration is constant, then this graph is just a horizontal line. And if we look at one moment, an initial moment we'll call t0, and some later moment we'll just call t, we can figure out what was the change in the object's velocity between those two moments, because we know that the area under that curve, that area of that box, is equal to the change in the object's velocity from this moment to this moment. So delta V is equal to that area, which is of course the length times the width. There's our width, delta T, our time interval, and here is our length, which is just A, that constant acceleration. So the area is the length times the width. It's this value of A times delta T. Well, let's summarize that over here. Delta V equals A times delta T. Change in velocity between two instants is equal to the constant acceleration times the time interval between those two instants. Key point, this is only true if that acceleration A is constant. Okay, there we go. There's our first constant acceleration equation. Let's examine it a little more closely. If I rewrite delta V as some V final, which is called V, minus V initial, which I'll call V naught, so that's my delta V, equals that constant acceleration A times the change in time. So that'll be some final time t minus initial time t naught. Looking at this equation, it may occur to us that this is the equation of a line in point slope form. This is like y minus y naught equals m, the slope, times x minus x naught. It's the same sort of equation. And we see that the acceleration will be the slope of the line if we graph velocity versus time. So over here, we can graph this. Well, let me make this point that what we've got here is a line in point slope form. So our second major conclusion here is that if the acceleration is constant, then this graph of V versus T will be linear, with the slope equal to the acceleration. So this graph will look like here at t naught, the velocity will be some value v naught. T naught, v naught, that's some known point. And this graph will be linear. I'm assuming here that we've got a positive acceleration, so this positive slope here represents the acceleration. The slope is equal to A, and so at some later time t, the velocity would be v. So we know the slope, and we know some one point t naught, v naught.